Hello, so this is a look at gravitational fields, which is part of the Year 13 topic of fields. You may have encountered fields in physics before, so you may have encountered electric fields, which is where you've got positive charges moving towards negative charge in such a fashion. You'll have thought about gravitational fields, or the idea of gravity is where you've got a body moving towards the Earth or a mass. You may have looked at magnetic fields before, where you have the field moving from north to south. The definition of a field is a region in which a body experiences a non-contact force. Okay, specifically, if you're asked to calculate gravitational field strength, then we've got to take into account the two equations that we've encountered before. The weight, the mass, times by gravitational field strength, which on Earth is 9.81 newtons per kilogram, and force equals mass times acceleration. Okay, weight and force are identical to each other. So weight is measured in newtons, force is measured in newtons there. So gravity, or gravitational field strength rather, has got two specific units. It can either be measured in newtons per kilogram or meters per second squared, as this is the unit for acceleration. So if we rearrange both of these equations, acceleration is force divided by mass. Gravity, or gravitational field strength, is weight divided by mass. So by definition, okay, gravitational field strength is force or weight divided by mass. If you are asked to define gravitational field strength, it's force per, that's what that solidus line represents, unit mass. But you have to be more specific on that for a second mark, okay? And that is when a small test mass is placed within a field. Okay? So gravitational field strength is force per unit mass for a small test mass placed within a field. If we think about the way gravity acts, we can think of it in two ways. We can think of it as uniform across a small area. So if I drop this pen at any point in this classroom, then it will follow that straight line. If you think of the Earth as a whole, okay, then it's a radial field, and that's the idea that if it's dropped at any point, that it would follow this pattern. Okay, think of gravity on a small scale as following a uniform field, and a radial field applies on a large scale. And that is gravitational field strength.